friends, welcome back to another video. It's me, Ashol the Brilliant, and you're watching Learn with Ashol. And in today's video, we're going to talk about numbers. And I would say they're everywhere. Numbers are everywhere. And I don't know how our lives would be if we didn't have numbers. Numbers are really important. And why is that? Because we use numbers to identify, count, measure, distribute, and understand different aspects of nature. For example, buildings use numbers in different ways. They use them to identify a building from other buildings. They use numbers in the same building to separate floors and apartments from each other. Hotels use numbers to identify different rooms. Cars use number plates. We use numbers when we're making measurements in construction work, money calculations, when we communicate with people through phone numbers, and when we measure time. And the list goes on and on and on, and I would like to encourage you to take a look around yourself and notice the presence of numbers and appreciate. One of the primary uses of numbers is that they represent values. For example, money. Dollar bills like $5, $10, $20, they all, like numbers like 5, 10, 12, I mean, not 12, but like, 20, they all represent the value of the dollars, right? So they're giving the dollar, the money, its value. The same way we also talk about distance, like the distance between two cities is, say, 50 kilometers. So two, as in itself, the cities, the number of cities, we're being able to like talk about that because we know how many cities we're talking about, right? And the distance, otherwise, 50 kilometers, that's like 50 is a number, we're using that to understand how much the distance, or like how long the distance between two cities is. Genius minds all throughout history have developed their ideas of numbers, and they group them for us. And our job today is to learn and build on them. They call these groups as sets. You remember those? It's okay if you don't, because we're going to quickly review those. We're going to review sets before we get into our current topic. So, what are sets? A set is defined as a collection of things or numbers, because we're talking about mathematics, we're going to say numbers, but yeah, it could be of anything else too. With the conditions being that each element or member be well-defined and distinct, which means that we know well-defined. By well-defined, we mean that each member, we know exactly what it is, and by distinct, we're saying that not two elements or members are alike. Okay, and yeah, we can call the members different things, elements, terms, if we want, right? And the order in a set doesn't really matter, but when we're writing long lists of numbers, we prefer to write it by convention in ascending order to avoid mistakes and confusions. The first set of numbers that we're going to talk about are called natural numbers, and these are the same ones that we learned in our childhoods when we were taught counting. They start with 1 and then 2, 3 and then 4, and the list goes on potentially to infinity. And yeah, these are natural numbers, and they if I were to write them in a set, I'd write them like this, and natural numbers are represented by the capital letter N. The next set of numbers that we're going to talk about is called the set of whole numbers. And what are they? Well, whole numbers are exactly that. As their name implies, they're whole. And that means no fractions or parts. And you might be wondering, what's the difference between whole numbers and natural numbers? Well, let's take an example. Say I have 5 apples and I have 4 friends, right? And the 5th one's me, by the way. So we have 5 apples, and I'm gonna share my apples with my friends, and I'm gonna eat the fifth one myself, right? So I have no apples left, right? Before giving my apples away or like sharing them, I could say I had 5 apples, right? 5 apples. But now, what am I gonna use to represent no apples in math? You might say 0. 0 exists, right? Well, back then 0 didn't exist. I can say that now that like I have 0 apples left, but back then they didn't have that number, and somebody invented it back then, so that now today we're using the number 0. And when they added the number 0 into the set of natural numbers, it became the set of whole numbers. And yeah, so that's the only difference. It just starts with 0 and it goes like 0, 1, 2, 3, and it's the same thing on to infinity, positive infinity. And one thing that you might have noticed in the set of whole numbers is, if you haven't, I'm pointing it out right now, that the set of whole numbers is a superset of the set of natural numbers. How? Because if you notice, all the members or terms of the set of natural numbers are also present in the set of whole numbers. It's just an addition of 0, right? That's the difference. But because of that difference, natural numbers become a subset of whole numbers. And they become a proper subset because all the members of natural numbers are present in whole numbers, but whole numbers have at least one extra member, and that extra member is 0. So we're using our set knowledge again, and yes, to finish off over here, we're just going to say the set of whole numbers is represented with a capital letter W. Sometimes we come across new situations which might be opposite to our normal situations. So let's take an example of this. Say we have a number line, and going to the right on this number line by convention is considered positive. Then what about going to the left, or the opposite direction? That will be represented by negative numbers. And obviously you're going to move from a particular starting point, right? That you're going to originate from somewhere, right? You're going to move right from a particular space, position, and you can do the same. You can move in the opposite direction to the left from that same particular position. And that position is represented by 0, and you have to keep in mind that 0 is neither negative nor positive. And the set of integers is represented by the capital letter Z, and it includes the previous sets again, like the set of natural numbers and a set of whole numbers, but now we're adding negative numbers into that the whole number set, and that's how we get the set of integers. And so the set of whole numbers is a subset, just pointing out, it's a subset of the set of integers. The next class that we're going to talk about is called rational numbers, and these are those situations where we run into fractions and parts, right? We were going to get to that, I told you guys. So now we're here. Examples of fractions are like 1/2, 1/5, 1/4, 1/8, 1/6, etc., etc. I mean, like, it's not only like 1 out of something. It could also be like 3/4, you know, stuff like that. And yeah, the possibilities, you could say, are limitless in one sense. But that is what the set of rational numbers is all about. Like, in a general sense, we can say any number that can be written in the form of P over Q, where P and Q are both integers, provided that Q is not equal to 0, because otherwise the fraction will become undefined, and we don't want that, will be called rational numbers. And they're called rational because it's the ratio between two numbers. However, not all fractions are considered rational numbers. I need your attention over here, because rational numbers are only those numbers which can either have whose fractions either have repeating decimals or terminating decimals. By that I mean something like, say I have 325 over 100, right? Its decimal will be 3.25, and it's like simplified form, you could say, is 13 over 4. And for repeating decimals, we have like the example of 0.333333, it goes on, right? But like you can write it in a fraction form as 1 over 3. So yeah, these are two. And then also we have perfect squares, like square roots, like for example under root 9, under root 4, under root 25, etc., etc. The square roots of, like, or you could say what's called the perfect squares of numbers are included in rational numbers. Yeah. And also integers whose denominator is 1 are also considered rational numbers. And the set of rational numbers is represented by the capital letter Q. Yep. So the next class that we're going to be talking about is the set of irrational numbers. And these numbers, quite literally you could say, are the numbers that cannot be written in the form of P over Q, the general form that we talked about for rational numbers. But a better way to put this is that these are the numbers which do not have repeating, terminating decimals, or any sort of pattern that we can notice, right, in their like value. So these numbers are included in irrational numbers, and common examples of these are like the ratio of the circumference of a circle to its diameter, which is also known as pi, and Euler's number E, which is taken as the base for natural logs, and we have the golden ratio phi. And also all the numbers whose square root, who do not have like perfect squares, whose roots are not perfect squares, are also included in irrational numbers. And the set of irrational numbers is represented with the capital letter Q dash. Okay, so the last set that we're going to talk about today is called real numbers, and it consists of all the rational and irrational numbers, and you could say any number, all numbers that can be written in the form of a fraction or decimal. And real numbers include all natural numbers, whole numbers, integers, fractions, terminating decimals, repeating decimals, non-terminating decimals, etc., etc. And the letter capital R represents the set of real numbers. And from our discussion so far, we can conclude that, since we've actually done this for a few sets, that the set of natural numbers is a subset of the set of whole numbers, which is a subset of the set of integers, which is a subset of the set of rational numbers, which is in turn a subset of the set of real numbers. So this, we can conclude now at the end of this, that the set of real numbers is a superset of all the other sets that we've talked about today. And with this, I leave you guys for today. That's it for this video, and be sure to subscribe for more and like so that other people find this video. Share it if you find it helpful, and you'll actually see me in my other videos coming up soon. So stay tuned and keep learning.